In modern production, conventional clamping fixtures are often the biggest cost driver. Until now, each new part required its own fixture. This costs an average of 10,000 euros to 50,000 euros per shot, plus enormous storage costs and long setup times. This is now over. The solution is virtual clamping. Today we introduce you to the process of digital clamping. The revolution. With just one universal reusable part fixtures, you can replace the majority of your previous clamping fixtures. They clamp virtually instead of physically. The advantages are obvious. You save a lot of time and money. You drastically reduce your storage capacities. Your production will be much more efficient and flexible. Studies with major car manufacturers show that thanks to the enormous savings on fixtures, the investment in digital clamping pays for itself in many cases in the first year. Let's jump right in. Here's how to.
Hello, welcome to our webinar on digital clamping. My name is Benjamin.Ostrowski. I represent the Witte company here today. Together with our partners, we would like to show you today a little bit about virtual measurement worlds, where we stand in development. First of all, as I said, I represent the Witte company, which was founded over 50 years ago from classic contract manufacturing for the aerospace industry, which we are still allowed to do today. But in recent years, in recent decades, it has become known for IST-part solutions in the field of part measurement fixtures in the metrological environment. We particularly stand out with our AluFix system, through our modular system, which certainly represents an industrial standard in many areas today on the measuring machine. We have solutions for small, simple CMMs, perhaps in a small measurement environment, to large measuring houses. We round off this product portfolio with our roller plates, with our fixed base plates. Here we can load measuring volumes fully automatically. We can bring products from A to B, and, very importantly, when we are standing in the measuring volume, our plate represents a similar flatness on the plate as well-known classic measuring plates. Our products portfolio is rounded off by our vacuum clamping technology. We also have many solutions in the field of standard, that is, catalog goods, to support companies in being able to clamp their products well on the milling machine, on the production machine. This is also rounded off by our project idea here in the field of vacuum clamping technology. We can implement individual solutions for you, for our customers. In addition, there is our new product range, the V Precision, which is what we are talking about today. We display the measurement recordings in the entire process, which can be very flexibly approached to the recording points. This product range is rounded off by our Witte Core. Our Witte Core provides the interface between the various software products. The interfaces for your automation solution, the interface for your measuring system, or even to your measurement software. That is the part we perceive here. Of course, we can't do it alone. So I would now like to hand over to our next partner, Toby.
Hello, Tobias Knoke from Duwe-3d. Thank you, Benjamin. In this webinar today, we present our product D3D Digital Clamping Plugin for Polyworks Inspector. A plugin for Polyworks, which maps the entire process of digital clamping, from the definition of the measurement fixture to the 3D data acquisition by scanning and evaluation, as well as the control of the FEM simulation software. Before we take a closer look, I would like to briefly introduce Duwe-3d and myself once again. I have been in charge of customer solutions at Duwe-3d for 8 years. Duwe-3d itself has been a partner of Innovmetric in the field of sales of Polyworks software in Germany, Austria, and Switzerland for 27 years. And as many of you probably know, for a few days now it has really been part of the Innovmetric group. We not only distribute Polyworks in German-speaking countries, but also offer customers solutions that go beyond the standard of Polyworks functionality by programming software around the Polyworks world and offering special solutions for further possibilities. In this context, we became aware of the topic of digital clamping, and according to customer information and in cooperation with partners, we have built a plugin there that enables Polyworks users to carry out and map this complex and technologically high-quality process from their usual environment, and we would like to introduce it to you now. The conclusion of this round of introductions is Dr. Ingo Hahn. There you go.
Yes, thank you, Tobias. Ingo Hahn, Cadence Company. I have the honor of presenting the simulation part in this webinar. As a former MSc software within Cadence, we are responsible for the complete simulation of physical systems. I myself am a product manager in the product range of Simufact, production simulation. And that's where our virtual fixture solution comes from, which is part of the digital clamping environment presented here. We are now looking forward to presenting this solution to you, which is quite valuable as a community, a joint solution of various important components. On the one hand, the advanced part fixture for measuring the part geometry, then the measurement data acquisition and measurement data processing with Polyworks, and finally the simulation to perform virtual clamping. Let me briefly say a few words about the motivation for our digital clamping device. The classic use case of virtual clamping is at home in the automotive industry. There, more precisely in body construction, where high demands are placed on geometric accuracy. The conventional process naturally starts with the pressed parts, which are then clamped in a part-specific clamping fixture. There they are scanned, and the geometric image of the parts is measured in evaluation software such as Polyworks. This requires physical part-specific clamping fixtures, which also means increased effort for the operating team. And above all, it generates high costs for the production, storage, and maintenance of these fixtures. Where is our new innovative approach to virtual clamping fixture? The part scan is carried out on a non-part-specific clamping fixture, which is usually horizontal and consists, for example, of 3 mounting points on which the part can be placed relatively easily. The geometry of the part is brought into the target coordinates in the computer, which come from the vehicle coordination system. In other words, reoriented into the final orientation and clamped into the final assembly according to the specifications of the RPS system. There, it can then be measured virtually. This significantly reduces or eliminates the need for part-specific fixtures. They simply need significantly fewer of these generic fixtures than they have to keep in stock for part-specific fixtures. In this way, we are realizing significant savings potential.
Today I am pleased to present our V-Precision system at Witte, a whole new product group. Developed for the virtual environment, of course at its core for virtual clamping, the system allows us to approach pickup points flexibly, We work with a 5-axis system so that we can also reach hard-to-reach geometries. At the top end, we work flexibly. We can exchange top ends according to customer requirements, change them, or the customer can do it himself. In other words, it can be a reference sphere holder. It can be prepared for an oscillating procedure. Here we are flexible and completely geared to the customer's wishes, what his idea behind it is, how he has worked out something with his measuring machine manufacturers, with his measurement technology. At the same time, we have a second pillar with a sphere on the front in the x-axis. Targets can be applied here. We can use the sphere to measure, and we can make a reference to the upper top end. The pillars can be moved freely on a grid plate or on an existing roller plate. We can also go to a turntable. We can also create a new plate individually for the existing measurement environment. The pillars can be easily moved with a Witte system, which means in an eventual one-handed operation, it should be simple, it should be modular. In this example, you can see the so-called starter set from Witte, which means that we are starting with 3 pillars, because the majority of measuring machine manufacturers, the manufacturers of measurement technology, have signaled to us that 3 pillars is a good concept. We can also map initial tendencies towards a 4th or 5th pillar. Our specially developed Witte core system, our own software, has the option of having a 4th pillar right from the start, which means that the customer wants to have a 4th pillar right from the start, or a 5th pillar, or maybe a 6th pillar. Although it has to be said here that at some point the meaningfulness has to be questioned, we have the possibilities to expand the number of columns, or, of course, for the first delivery, in order to be able to react flexibly from small components to very large components, or for further development in the field of virtual clamping. In order to be able to represent a simple and safe part fixture as a repeatable one, we work with a camera system which makes it possible to query features that need to be correctly positioned after an initial teach. If the part is correctly positioned, the system recognizes and can release a measurement, for example on an automated measuring cell, or to give a simple feedback if the part is correct. So, we are now standing here in front of the Witte V Precision Universal fixture, and today we will take a look at how it works overall with Polyworks in the digital clamping workflow. The fixture can be controlled from Polyworks. All functions of the device are supported from within Polyworks. We can call up the stored positions that are stored for each component in Polyworks so that the system is easy to use for users on the shop floor. To show you this in practice, we open a part-specific project in Polyworks, move the fixture to the part-specific position, and place the part on the fixture. I bring a new part to the measurement and set the fixture for the given part. The pillars proceed according to the specifications stored in Polyworks. I position the part according to the specifications in Polyworks. And use the integrated camera with virtual template for fine positioning. After positioning on the fixture, the measurement program starts in Polyworks. We are now starting the process of data generation for data preparation for simulation. Various parameters can be set, and the process is running. The creation of the objects is complete. Polyworks has created surf curves and meshes, and this data is now passed to Polyworks Modeler to create a clean mesh. The processed data has been transferred back from the Polyworks Modeler to the Polyworks Inspector without user intervention. We now see the dataset with processed outer edges, with processed irregular inner edges on this geometry element, and with prepared internal control geometries, including the extrusion of wall thicknesses. This processed data model is now being prepared for FEM simulation. And then the FEM process is started in the respective stored software. To do this, I call Run FEM Simulation and start the process.
Yes, the simulation is running, and I would like to use the time briefly to illustrate the simulation process. We have already seen the first one. The scan that has just been pre-measured on the non-part-specific fixture is cleaned and triangulated in Polyworks. Of course, this scan now serves as a template for the simulation model of the real component geometry. In the background, we have automatically networked the nominal CAD geometry for finite element analysis without user intervention. And this is now morphed to precisely map the geometry of the scan, and thus the real component geometry. Of course, gravity acted on the scan during the measurement. This is now compensated for in the first simulation step in order to provide a gravity-free geometry of the real component. The result, the geometry of the real part, is then aligned with the vehicle coordinates and clamped according to the specifications of the RPS specification. The result is a virtually clamped real geometry of the part. Our virtual fixture solution is robustly suited for complex use cases. It is capable of imaging large, non-rigid parts with more than 10 millimeters of distortion or deflection. The non-linear finite element analysis accurately captures the clamping behavior, and the solution also allows the determination of the reaction forces generated by the clamping. If information about preloads is available, for example from a previous forming analysis, this can also be taken into account in order to map realistic component stiffnesses. Finally, I would like to mention again that we can also map ZSB with our solution to simulate the assembly of different parts into a common assembly. That is the clamping of different parts together in a common assembly.
After the simulation, the analysis of the simulated scan starts. The analysis of the simulated part is available. Deviations are documented by means of color maps, and the final dimensions are summarized in a report. After uploading to Polyworks data loop, the data is available for viewing via the web interface available. At this point, we would like to present the benefits of our community work, our product. For the V-Precision, we can say, we have created a modular system that can be flexibly expanded and integrated independently of the measuring system, even in an automated solution. We can provide the interfaces here, as we heard today. We are talking about a refinancing of less than 1 year. All of these are benefits that we are not otherwise aware of in the market.
Yes, thank you. We then also offer a system that, as we have seen here, can measure individual parts, very reliable, and also assemblies. And the individual parts can of course be the components from the press shop, but also assemblies that have already been joined. The joining processes themselves can then also be taken into account, so spot welding, line welding, clinching, and what is now very important to mention. Of course, we have now seen an example from car body production in automobiles. We are convinced that this technology can also be transferred to other branches of industry, such as aerospace technology.
Yes, I would like to suggest exactly these systems to you as a Polyworks user. And I would like to conclude by saying that we are pleased to be able to offer a product that makes exactly these capabilities usable and available to you as a Polyworks user in the familiar environment.
So, now we are slowly coming to the end of our official part of the webinar. Thank you so much for your participation. We would now like to move on to the area of questions. We hope to have brought you closer to the process of digital clamping, and we would like to answer all other questions as best we can and as many as possible afterwards. Thank you very much.